Hello, welcome fantastic physics students. This is going to be a force video. And so what I'm going to do right here is just quickly do a force problem for you that kind of brings in a lot of the kind of ideas we've talked about. And really, force equals mass times acceleration. This is it. I mean, this is a whole lot of physics right here. And we're going to be centered right here for a long time. So just force equals mass times acceleration. If you can't think of anything to solve the problem, at least try this. So you pretty much are going to have that in most everything when we're talking about physics and mechanics. All right, so let's say there's a guy. Here he is. His name is Peter, and he's walking along, and he sees a lovely lady. And he sees a lovely lady over here. And let's say her name is Mari. So she's got there's her lovely eyelashes. And she's got her hair right here. And he's like, oh, wow, she looks pretty. So he says, hi, my name's Peter. She says, hi, I'm Mari. And he says, you want to go on a date? She says, sure. And he says, what do you want to do? And she says, I want to go skydiving. So they go. And so Peter says, hey, how about we take my personal jet that I built myself in my backyard? She says, oh, wow, you're amazing. So anyways, so they're up in their jet, and Peter's got his friend, and this is what Peter's jet looks like. And I know it looks a little weird, but it really is a good jet, and he built it himself. And so Peter has his friend here flying the jet so that they could go skydiving together. And so here they are, and they're in the back here, and so there's Mari and Peter, and he says, okay, time to go. So he shoves her out. Whoa, she's flying. She says, ah. Okay, and there's her hair is going straight up like this. And then Peter, he knows how to do this, so he runs, or he jumps out, and he catches up to her. So here they are. And all right, so in order for Peter to slow down to be the same speed as her, he had to open up his arms, and that caused him to have a greater drag force. It caused him to have a greater upward force of the air on him. So let's say that Peter is 90 kilograms, all right? And let's say that upward force that he experienced that slowed him down so he could catch up, or that slowed him down so he could go the same speed as Mari, was 150 newtons, right? And so he's got this 150 Newton force, and so the question might be, what is the net force that's acting on Peter, and then of course on Mari, because Peter wanted to. What he's done is he's basically made his body stretched out so that he's at the exact same speed and acceleration as she is. So what he did, because he's very smart with his physics, is he just spread his body out in such a way that he is experiencing the same upward force of air as she was. In order to catch up with her, of course, he curled himself up so he's experiencing much less than this 150 newtons. And she, this is her first time, and this is just, the greatest date of her life, because Peter's just incredibly awesome. So what's happened is she doesn't know what she's doing, so she's just kind of flapping around. Oh, whoops, they forgot their backpacks. That's kind of important there. Okay, so anyways, that's backpack, if you're wondering. There's some straps. Okay, so the question might be, what is the net force? What is the net force that's acting on Peter? Okay, so he's got the air pushing up on him at 150 newtons, right? Well, Peter, we said, weighs 90 kilograms. So the force of gravity is going to equal his mass times acceleration of gravity. So if we took that, his force of gravity is going to be 90 times 9.8. So 90 times 9.8 should be 882. Let me see if that's right. Yep. So the force of gravity here equals 882 newtons, and that's going to be pushing down on him, or pulling down on him, because of the mass of the Earth. All right. And so we learned that Newton's law says force net equals mass times acceleration. So so we have 150 newtons pushing up on him from air. So we would subtract that from that to get our net force. So 180 minus, or 882 minus 150 equals 732 newtons. So this is his net force, right? Equals mass times acceleration. We know his mass is 90 kilograms times acceleration. So let's divide both sides by 90. And we will find that acceleration equals 8.1 meters per second squared. So not quite the acceleration of gravity, because obviously he's going to be experiencing an upward force from air as he flies through the air. And of course, like I said, we could figure out, okay, when he was catching up to her, what did he do? Well, he curled himself up, and so his upward force, let's say in his first instance, was only 50 newtons, and that allowed him to catch up to her. How do we know that allowed him to catch up to her? Well, if it's only 50 newtons, then that means his net force would have been 832 newtons, right? Divide that by 90. So let's see, 832 divided by 90. Oh, whoops, did that wrong. 832 divided by 90 equals 9.2. This acceleration, 9.2. So not quite the acceleration of gravity, but almost there. So see, that would allow him to go much faster, much more quickly. So that's what allowed him to catch up to her. And then when he got to her, he spread his arms out so that they could be going the same. And so then it's, it's more romantic because they're at the same level instead of her just going, I'm going to die. But anyway, she's having a good time. All right, so that's kind of a quick little example of, how would I take a situation like this and analyze the different forces acting on something, come up with our net force, and then come up with a new acceleration. Because obviously when someone jumps out of an airplane, they can't accelerate indefinitely at 9.8. There's always going to be air pushing up against them. So in fact, they probably never will accelerate at 9.8. So the best he could do to start off was 9.2. All right, cool. So hopefully that helped with a little bit of a force problem there.